Okay, good afternoon, and welcome to the AP Calculus BC exam for 2018. We're going to be working over the FRQs, questions 1 and 2. We have 15 minutes per question, and the calculator is required for these problems. Okay, number 1. If the grain is being added to the silo. At t is equal to 0, the silo is empty. The rate at which grain is being added is modeled by the differentiable function g of t, where it's measured in cubic feet per minute from 0 to 8. Using the data in the table, approximate g prime of 3. Using the correct units, interpret the meaning of g prime of 3. All right, so since we have a table given g of t and we're looking for g prime, we're going to have to use our average rate of change. G of b minus g of a divided by b minus a, which is, we're going to take the values closest to 3. So we're doing g of 5 minus g of 1 divided by 5 minus 1, which is 20.5 minus 15.1 divided by 4. If we subtract these two decimals, we get 5.4 divided by 4. And this gives us I do have my calculator with me. 5.4 divided by 4 is 1.35. Now it says we have to use the correct units here. And because g of t is already cubic feet per minute, I mean this is going to be cubic feet per minute squared. And if we make it into a sentence just to be safe, we're going to say at t equals 3 minutes, grain is being added to the silo at a rate of 1.35 cubic feet per minute or per minute squared. Okay. Write an integral expression that represents the total amount of grain added from 0 to 8. So that's going to be the integral from 0 to 8 of g of t dt. And using the right Riemann sum with 4 subintervals, find the value of this integral. So a right Riemann sum is basically just rectangles. So it's going to be base times height plus base times height plus base times height plus base times height, because we're doing 4 subintervals. For the first subinterval, the base is 1 minus 0. And for the height, we're going to be taking the right value. So 15.1. Next, the base is 5 minus 1. And the height is 20.5. Then for the third rectangle, the base is 1. And the height is 18.3. And for the final one, the base is 2 and the height is 22.7. Okay, and because you do have a calculator, you can go ahead and plug it all in and figure out the final value, which is 160.8. And this means that 160.8 cubic feet of grain is added to the silo during the first 8 minutes. Okay. See. The grain in the silo is spoiling at a rate modeled by W of t. It's measured in cubic feet per minute. Using the results from part B, approximate the amount of unspoiled grain. Okay. So if we're going to talk about unspoiled grain, we're going to have to take into account basically the grain being added. The grain added. And we're going to have to subtract the spoiled grain. Spoiled grain. Now for the grain added, we're going to do the integral from 0 to 8 of, what was it? It was g of t dt. Oh, you know what? Let's put it into one integral. G of t minus wt dt. Now, the value of the grain being added, we already figured it out. That part was 160.8. But we're still going to have to figure out how much grain is spoiled by doing the integral from 0 to 8 of wt. That's going to be done with your calculator. Plug it in, and we get 61.749. This means that 61.749 cubic feet of unspoiled grain. Unspoiled grain is in the silo. After 8 minutes. Okay. Based on the model in part C, is the amount of unspoiled grain increasing or decreasing? Well, in other words, this is basically saying, is the rate at which you're adding grain, is that greater than the rate than the grain spoiling? Is the rate of the grain greater than the rate of the spoiling grain? That's the big question, right? So in order to answer this, we're going to take our g function, the rate at which we're adding grain. We're going to plug in the 6, and we're going to subtract w of 6. When you plug this into the calculator, you're going to get 2.237. And because the answer is positive, that means our derivative is positive. So in other words, the amount of unspoiled grain is increasing. Since g of 6 minus w of 6 is greater than 0, the amount of unspoiled grain is increasing. At t is equal to 6. Okay. I won't say minutes just in case. And number 2. A particle moving in the xy plane has a position x of t, y of t, where the derivatives are given. At t is equal to 0, the position is 1, 2. So that right there sounds like an initial condition to me. The figure above shows the path of the particle. Find the position. Since we're given velocity and we want to find the position, we're going to have to use the formula f of x equals the integral from a to x of f prime of t dt plus f of a, right, where we use our initial condition. But we're going to have to take this formula and apply it to vectors. So the position of the particle at 2 seconds, or whatever it is, at 2, equals, for the x component, we're going to do the integral from 0 to 1, because that's the initial position or the initial condition, from 0 to 1. Oh, just kidding. From 0 to 2 of x prime of t, which is cosine of t squared dt plus f of a. That's where the initial condition comes in. That's where we plug in the 1, comma. Now for the y component, we're going to also do the integral from 0 to 2 of y prime dt plus f of a. Now for this one, the initial condition is 2. That's the position of the y component. Now, This is going to have to be done with your calculator. There's no other way around that. So S of 2 equals 1.461, comma, 4.268. That's the position of the particle after 2 seconds. I don't think it says the units. So 1.461, comma, 4.268 is the position of the particle at t is equal to 2. All right. Find the slope of the line tangent to the particle's path at t is equal to 2. Well, in order for us to find the slope of the tangent line, which is dy dx, we're going to have to take dy dt and divide it by dx dt. We are not doing the quotient rule. We are just taking the two derivatives and dividing them. So y prime is et sine of t squared, and x prime is cosine of t squared. Now all we got to do is plug in the 2 using a calculator. All right. You are not going to find the derivative. This is the derivative already. Just go ahead and plug in the 2. dy dx at t is equal to 2 equals 8.555. That's the slope of the tangent line. Find the speed of the particle at 2 seconds. Find the acceleration vector. Okay, so two different questions here. First, we're going to go ahead and find the speed. And to find the speed of the particle, we are going to do the square root of x prime of t squared plus y prime of t squared. Okay. And we're going to plug in the 2. So we already have the derivatives, right? So you're going to take your calculator and go ahead and plug in cosine of t squared. In other words, 2 squared. But don't forget to square that. Plus y prime. Y prime is et, but plug in the 2, times sine of t squared. And all of that still has to be squared. And when you plug it into your calculator, you get 5.63. That's the speed at t is equal to 2. Now there's a second question to this. Find the acceleration vector. Well, if the velocity vector is cosine of t squared, comma, e of t sine of t squared, then all we got to do is take a derivative. But really careful, because one of them is pretty simple and the other one requires a product rule. So the acceleration vector is negative sine of t squared times 2t, comma. Now we got to use the product rule. And it goes the first times the derivative of the second with the chain rule plus the second times the derivative of the first. And then we plug in the 2. A of 2 equals negative sine of 4 times 4, comma, e squared cosine of 4. And you don't have to do this. You don't have to show it on your actual work. You can already plug it into your calculator. I'm just showing you what it's becoming here. E to the 2. But when you get the final answer, we get an acceleration vector of 3.027, comma, negative 24.911. The final part for question number 2. Consider a rectangle with vertices at 0, 0, x0, xy, and 0, y. At what time is the perimeter of the rectangle a maximum? Okay, so this question is a little bit tricky, but take it one step at a time. First, let's go ahead and draw the rectangle. So we have the point 0, 0. Then we have the point x comma 0. We have no idea what x is, so I'm just going to throw it and put it right here. That's your x of t comma 0. Then the point 0 y of t, that's going to be somewhere up here. 0 y of t. And then the final point x and y would have to finish my rectangle. X of t, y of t. And there it is. There's your rectangle. When is the perimeter at a maximum? Well, let's start with the basics. When you do the perimeter of a rectangle, it's going to be the length plus the width plus the length plus the width. So 2L plus 2W. And if you want to maximize that perimeter, well, we're going to have to find the derivative. dp dt with respect to time. So the derivative is going to be 2 dl dt plus 2 dw dt. We make the derivative equal to 0. And you know what? I'm just going to write L prime for short. We're going to try to solve them. So you can subtract either of the pieces. Divide by negative. You can divide by 2. Okay. Actually, you know what? I forgot that we have an equation for x prime and y prime, huh? So we actually don't even need to solve this further into it. I'm going to backtrace 2 steps right here because, again, we have L prime and W prime. Like, I forgot to look at my rectangle. 0 is equal to 2. We're going to call this the length, and we're going to call this the width. So if you think about it that way, the length equals x of t. So L prime is going to be x prime. So that's going to be dx dt. At the same time, the width is going to be y of t. So the derivative is going to be y prime dy dt. And by setting it equal to 0, since we have equations for both of these functions, given equations, you can go ahead and graph it on your calculator and find the critical point. When you graph the function 2x prime plus 2y prime, and you find your critical point, aka when the derivative is equal to 0, you're going to get 1.722. And because you're actually seeing the graph, you can see that the derivative of the perimeter is positive in the first interval and negative in the second interval. So, at what time t is the perimeter a maximum? At 1.722. The perimeter of the rectangle is at a maximum at t equals 1.722 because p prime changes from positive to negative. Okay. So that right there concludes the first portion of the FRQs. In the next video, I'm going to see you guys for the no calculator portion, where we're going to be tackling 4 questions. We're going to have 1 hour, and hopefully we can maximize our points. But yeah, thank you. See you next time.